Hello guys, welcome to another procedural modeling tutorial. In this one, we're going to try to create, a cable system like this. Almost like something like, audio interface kind of like structure with a lot of cables. Like they're in certain rows and they're connecting from one port to another. Okay. And yeah, let's go start from scratch. I'm going to hide that and create another geometry. Oops. And instead of it, I'm gonna go create a box. Okay, now make it bigger, so maybe 4 unit for the width, and then 10 for the height, and 4 for the width again. I'm gonna copy parameter and paste relative reference in here, and then I'm gonna divide that by 2. Okay. Alright, and then afterwards we can also go create a blast node. The reason we're going to do that is basically getting one face. I don't want it to be on every face, right? So let me just blast out the first one and reverse delete. Now select this. We got this x direction face. Let's take a look at the normals. I think there's no point normal, so I'm gonna go create a normal node just to be able to get normals on the points. Right. Alright, I'm gonna go create a poly expand. The reason I'm doing that is because I kind of wanted to shrink it in a little bit. So yeah, like that. That way I'm not having anything on the edge, basically. So we can offset a little bit longer. And then we can do a scatter. To scatter a bunch of points on this plane. Now they're all gonna inherit the direction of the normal here, which is gonna really helpful in the future, right? So on the other side, I'm going to create the base for the cables. So this is gonna be a circle. For this circle, I'm gonna try to make it a polygon. And it's going to be an open arc, and arcing angle will be from 90 to 270. Take a look at that. Yeah, something like this. Okay. Maybe I want the other side. Let's take a look at the box. Okay, well, let's take a look. I'm going to do a copy stamp to see what I'm getting here. Yeah, they're not facing the right direction, so I'm gonna go to the circle here and change that to YZ plane. Okay, that feels good. Cool. Now this could be your setup, but you can see, well, there are artifacts like this. This is over the border. And they're kind of like in a random place. Again, this may be something you want to have or not. Okay, let's say this is like a more dedicated machine, and it does have, cables, ports in a row kind of like way. Multiple rows, so it's not going to be as random as this, at least on the Y direction, that is. Okay, so to fix that problem, then we have to do something with the points that we're getting here. Now they are not aligned in certain height, so we can do a attribute angle here. Oops, to fix that. Align to rows. Okay. I'm going to say your position dot y will be a rounded up version of your position dot y. Oops. Okay. After that, you can see now they're rounded up into this very even rows. In fact, if you go to the side view, it's not that clear. Oh, maybe that's because our values are like really small. So yeah, it's not that easy to see. But you can already see like the gap is like 1, 1, 1, right? For every row, there are multiple rows. We can make it more controllable by actually dividing this value by a channel called maybe a gap size. That name is clumsy. How about we call this guy row distance? Yeah, that makes more sense. So we divide that, round it up, and then times that back. Now that should make sure that the distance between the rows are the distance here we defined. So let's create that channel and make it maybe 4. Or maybe even 3. Cool. Now we have all those interesting rows. Back here to the scatter, I'm going to check off the relaxation so that their distance is more not even. Okay. And also I don't want the bottom one, this one. Right, so I'm going to say another attribute wrangle. I'm going to say delete bottom. Actually, Blast should do that. Should be able to do that. I'm using Rango for too much. Blast is actually capable of doing that because we can just check at position dot y is equals to 0, and we're going to do that on the points. Okay, that in theory should delete those guys. Let's take a look at that. Yeah, and then maybe we can then use this attribute wrangle to align to center. Because I wanted to move those points to the center here on the y direction, they're a little bit higher than the middle. Alright, to achieve that, I need to know where the center is. Okay, so I'm gonna go grab our panel here. Right, that's the panel, right? And we use that panel to get its center. Okay, so we're gonna say vector panel center will be equals to get bbox center of the second input, and then vector cable cluster center will be equals to get bbox center of the first one. And in my variable name really long. That's not a good habit when you're doing VEX coding. But it's actually really useful when you're doing game programming. You want your name to be really specific. So I have that habit. Anyway, so once we got all the centers, we can compare the y distance, right? So we can say float y distance will be equals to the panel center dot y minus our cable cluster center dot y, which will give us the offset we need to offset every point. So I'm going to say add p dot y plus equals the y distance. Right? That should move out the point to the center of this panel. Okay. Now we'll be able to see our copy result. Okay. But again, they're looking like really even. So I kind of wanted to make some changes to this. Okay. So another wrangle. I'm doing too much wrangles. Let's say random size. For the cables, I still want to keep the connections, right? The ports to be on the same height, but I want them to be having different lengths. That basically means I need to scale them differently on the, let's see, which direction I'm not sure. So we'll have to see. Oh, maybe we can take a look at it. Should be the z direction in this case. So I'm gonna say get a random number, float z size will be a random, and it's gonna be based on the point num plus maybe a channel called seed, right? But we can then fit that from 0, 1 to a different range. The range can be also defined by channels. So cable, or maybe just size mean, and then channel size max. Okay, Let's go create it, and then we can maybe make the max 2 and min is 0.1. Alright, and then we can say v at scale will be equals to set x and y will be 1, but for the z it's going to be z size. Okay, now back here to the copy, the z size should be able to drive the size of the cables. So some of the cables are longer while the other cables are not as long. Right? Cool. Now we can go ahead and try to tweak the amount of things we're happening here. Like the scatter here will give us, you know, how many cables we want to have, so we can have a whole lot of cables if we wanted to do that. You know what? I think I like this a lot of cable effect. It looks really cool. Okay. All right. But there's another catch. So when there is like a simulation happening, which we'll have to do, we wanted to lock those base points, right? Because they are supposed to be, you know, hooked up, so they're not supposed to be moving, basically. Right? So to be able to achieve that, I need to, before we use anything, before we pass in the circle, we need to do another wrangle here, and just to define the first and last point to be something not simulatable, right? So we can say in here, first and last points. And by the way, I kind of wanted to have more points. Okay. Say lock first and last point. Now that's actually very easy because we can get the first and last point. Int last point will be equals to the number of points and then -1. Because the index of the point is actually starting from 0. And then we're going to loop through all the points. Int p equals to 0, p is smaller than the number of points. And then we increment p. We're going to say, oops, if p equals 0 or p equals to last point. If that's the two situations, then what we have to do is we have to then say set point attribute. We're gonna set the attribute of glue to animation. This is a known attribute that the simulator or the solver will be able to see, and it's gonna, when it sees this attribute, it's basically going to treat that point to be, fixed or static. And then we're setting this point, right, number p, whatever point with this index, and then we're going to set the value to 1. Okay, run this. All right, let's take a look at that. I'm going to go to the panel here and split it to top and bottom, and right-click here and say geometry spreadsheet. You can see now there are 2 points, right? 29 and 0, which is basically, you know, the first and the last point. All right, fantastic. So now with that being created, we can see we're able to have a lot of points now on this guy to have, you know, glued results. Okay, yeah, enough of this setup. Let's actually do some simulation, right? So I'm gonna go create a null here and call this guy cable for sim, and then a dot network. Okay, and call this guy cable sim dot, and inside of it I'm gonna create a wire object, and in the wire object, oops, I'm gonna just load it in, right? So this is gonna be our cable for stem, and then we have to pass it to a wire solver to simulate. And going down here, we can create a gravity force, and the result goes there. Okay. Now go back to frame 1. We can now play the animation. Can see how they're dripping down like that. All right. Pretty cool. But then, well, some of them are dripping down nicely, but these are, because they're really small, it's not looking very nice. I guess I can change the range a little bit more here though. I kind of wanted to be able to see more cables dripping down, so size-wise the smaller size or the min size can be a little bit bigger. And max size, maybe it's pumping up too much. 1.5, I guess. Alright, now back here to my simulation. Turn that on and we can simulate one more time. Okay. Now go inside of it, we can set up some properties for the cables. Underneath the geometry, material, we can change the elasticity down here, the angular spring constant. This is going to be basically more or less the bending threshold. The smaller the number is, the easier it is to bend. So if I change that to 0.1, yeah, I should be able to see it bending down like a whole lot. Right? Pretty cool. Alright. So now back here to our simulation, we can drag the timeline because it's already cached. We can find like a position that we feel comfortable with. Maybe that. Okay. And then I'm going to cache it out. So file cache. And I can save it with the operator name, I guess. I don't need to save it with the head name. That's always a hassle. And for the operator name, we can call this guy cable cache. We just need the current frame. So save to disk. Oh, you know what? We have to say .bgl.sc. That's the format. Save to disk. Okay. Alright, I'm gonna go copy. Oh, you know what? We can just save to disk and change it to load from disk. That way we can go back to frame Y. You can see it's not changing because this one is now loading that file we saved earlier. So no simulation is involved anymore. We're done with the simulation. Alright. But now there's still kind of like too much of a uniform from this direction when you look at it. Right? So instead of simulating it, I'm going to use a different way to make variations on the z direction. So that's going to be a point vex operator. Right, I'm going to go in here, and then from the position we're going to pop it or use it to drive a anti-aliasing flow noise. Position goes there, and for the noise, I'm going to break it into vector to float. And then floats to vector. The reason I'm doing that is because I only care about a z. The others two will be 0. Right? And that's going to be the vector we'll add to our position. So, oops. We're going to say add. We're adding that to our position. Okay. And that goes to the position. Okay, you can see how they're kind of like getting a little bit crazy. So we can go back here, of course, go to the flow noise. We can promote all these parameters to the outside, so we can tweak it. Okay, so back here now we have all those settings. First of all, I don't want it to be having any roughness. It's kind of like doing too much of a damage already, and I think I like this already. But we can change the frequency to make it wave more or less, right, based on what you want. Alright, pretty cool. So with that being set it up, then we can then pass it through a poly wire to create actual cables out of it. And then we can change the division to maybe 12. Radius can be smaller, and we got cables. Right? How cool is that? Okay, this is looking really organic, right? But again, we're missing something. One thing I think we're missing is that we don't have a connector, right, to the very beginning. So we kind of wanted to add something like that in the beginning. Okay. So let's take a look at the polywire. And add some you know what, I don't really care. So let's actually start adding some connectors here. I'm gonna go start with the tube and make it a polygon, and then fill in the caps, go to selection, grab the faces, grab the top face, and we can go for polygon, poly extrude, and just insert in and extrude again. Going up. I'm not gonna do anything too fancy in this case. You could model this in Maya instead of in here, because it's not very easy to model in here. Yeah, to be honest. Okay, and another extrude, insert inwards, another extrude, and goes in. Okay, and maybe we can bevel these points. Oh, I'm not supposed to be beveling that. Sorry. Right, I'm extruding that down. Go to selection. I'm gonna grab this line and this line. I'm gonna do a poly bevel, right? And we can bevel these two lines and make them more like rounded. Yeah, that's about how much I want to deal with Houdini modeling. Alright, so we want to populate this guy to, again, our points. Let's take a look at that. And we can also get those points out by using a blast, because the information is still there. By the information, I mean the add glue to animation. If that's equals to or not equals to 0, right, I want to delete those points. Or equals to 0, actually, in this case. Equals to 0. So that we're only getting those points. That's actually the point that's actually on the panel, right? So we can do like a copy stamp. To position our our connector to there. But again, the size doesn't really look right. Right. So yeah, I'm gonna go create a transformation node so I can, not trail node, and I can drag the uniform scale to make them smaller, and of course rotate it like 90 degrees, negative 90 in this case. Alright, let's take a look. We can do like a merge to merge our base and the cable together. Alright. Well, that's pretty cool, but you know, it's not quite working yet. You can see that we have two problems. One is that these cable connectors, they are kind of like half embedded into the face. And also, as you can see here, well, that's not connected right away, right? So we have to do some tweak for it to work, although it looks pretty cool already. So let's take a look at that. First of all, when we're creating the tube, we don't want it to be sitting in the, you know, one unit down there. So we're gonna change the center to be the height divided by 2, so it's sitting on the ground. That should already push them out from the face. Right, so they're exactly sitting on the face. Okay, well, for the cables though, you want to move the cable outwards to where the end of this is. Right? So in that case, we kind of wanted to know where or how long this distance is. And that's going to be the distance of the this guy's bounding box on the X direction, right? So I'm gonna do a attribute wrangle here before we merge. Take that as reference. We're gonna again calculate the distance we kind of wanted to move our cables out. Okay, so float forward offset will be equals to get B-box center or B-box max of the second input dot x, right? And we're moving everything forward that much. So at p dot x plus equals to forward offset. Right. That should move them forward a little bit, right? And that little bit should be exactly the amount of, you know, the amount of, the length of this guy, basically. But again, you can see, well, that's still not looking very good. Maybe we can make those guys smaller size-wise. So I'm gonna change that to 0.05. Okay. And maybe we just don't offset that much, and I want it to be a little bit bigger. Oh, actually 0.06. And we can go to the offset, and then we can say minus another channel, offset, and then we can offset back in a little bit so that they're basically looking like they're from the hole there. All right, let's turn off the wireframe and take a look at the result. Okay, cool. Yeah, you can see that's a lot of really interesting variation already from those cables. All right, and they're all done procedurally, so we can go back and make a lot of changes. Okay, but yeah, I think that's everything I want to talk about. Of course, this entire workflow does require you to do a lot of experiment. I don't come up with this idea like right away without any problem. There are some back and forth to think about how to achieve this eventually. Right, so the step when I was trying it the first time, the step is actually very different. Right, so there's always ways to improve, to be, for sure. But it's still like really fun to do nonetheless. I'm gonna do another merge here just to get everything together from our box. Right, you can see now they're sitting on the box exactly there, right, and they're extending out. Maybe you can do a smooth shaded version. Alright, cool. So yeah, that's for it for this procedural modeling tutorial. I hope that this can help you to create something complicated when it comes to a lot of cables hanging around like this. Alright, thanks for watching. See you next time.